from Hainan University, and it's my great honor to be here to have this report. Oh, sorry. Can you hear me? Okay. As we know, the brain is really a very complex system. However, there are magic, like one-to-many relationship, like the brain is relatively fixed anatomical structure, but it can support rich cognitive functions. Usually, we can modeling the structure connectivity and the functional connectivity to modeling the brain function and the structure relationship. These four papers inspire me a lot. Like Honey's work have investigated the brain function and structure relationship very earlier, in 2009. And Park's review have systematically to report the functional brain network and structural network from cognition, from connection to cognition. Surez's work it's a wonderful review. It's just summarize the past decade, the significant progress in the field. And the money also investigates the local, functional, and structure relationship across a lifespan. However, this function and structure relationship just rely on fMRI data and DTI data. Myelin as a very important marker. It's not only isolate the signal transmission and provide some nutrient to neurons. However, the myelin imaging has not attracted a lot of attention in our field. A Gleich and his colleague use a T1 weighted and T2 weighted image, map the whole myelin map in 2011. Naturally, I come up with a question. If I substitute a DTI network with a myelin network to compute the fMRI-myelin relationship, would it yield consistent findings at prior study? I just downloaded unprocessed MRI data from HCP, and after data cleaning, we obtained a quality-controlled resting state fMRI, T1 weighted and T2 weighted imaging, about 198 participants. We first construct a microstructure covariance network. This network is a group level, and we threshold this network just keep the top 10% edges. Subsequently, we calculate the path length, equate the distance, and the communicability. Apply a regression model to predict the nodes' functional connectivity. That is to say, we term R square as the nodes structure and functional is corresponding. And the results is very reliability across different threshold value, and the pattern is similar with fMRI DTI. Like the panel D shows, in the uni model, the higher corresponding, and in the trans model, will be lower corresponding. The question two is, even though we have the group level results, I want to know what is the high order relation between the individual myelin-based structure network and functional network, like the left panel shows. G1 and G2 have the same node, edges, same degree centrality. However, G1 and G2 have totally different topological structure. G1 is two triangles, and G2 is a circle, and G3, G4 have different degree centrality. However, his topological is the same. They are both two triangles and one path. So, only from the edge or node level to capture the brain function or structural network is not enough. So, we just provide a very simple high-order framework. Like the panel B show, it's 11 OR bits. We treat it as a high-order feature. For each individual microstructure matrix and individual functional matrix, we just count the ORB's frequency for each node. And the matrix row indicates the nodes, and the column indicates the 11 ORBs. That is to say, we can compress any brain network into a mutual information matrix, and 11 times 11. So we can calculate the two mutual information matrix statistical relationship, and we can term this as high-order interaction. Our results show that this high-order relationship is significant correlation with some like individual personality score, especially for the gray bonus. Interesting, this result is mainly driven by the male participant. And we observed the decreased trend of the high-order relationship across the 3 age group, just from 22 to 35. Then we calculate the nodal microstructure functional relationship and just calculate the cosine similarity between the 11 high-order feature of the microstructure and the functional connectivity. The result is different with structural covariance functional corresponding. And this result also show sex difference, like some insular precuneus. If we use a KNN, we can distinguish the male and female with AOC of their 0.8. For the local high-order microstructure relation and relation analysis, we use different resolution, like the 20, 140, 120, 60, 13. We can observe the functional and microstructure high-order similarity can be preserved, regardless of the nodal resolution. Their high-order relationship is higher compared with random networks. And we use the artificial hub attack. This can significantly disrupt the network's high-order similarity. Even we use a static visual cortex attack, and they also can disrupt the high-order similarity. It's a summary. Summary is microstructure and covariance functional corresponding is similar with FMI, DTI. And the global high-order results are mainly driven by the male participant, and the high-order relationships can be preserved even with the graduate decreased scale. And the target attacks and the visual cortex attack can significantly disrupt the high-order similarity. Thank you for your attention. Sorry for the delay. 感谢大家。